Oh, here we go. 9-4, the last of the graphing. This is where all the graphing happens, actually, ladies and gentlemen. After this, I mean, we don't really deal with graphing that much more. I mean, not like this extensive of graphing. I mean, there's some basic graphs like, looking at stuff in standard position and things like that. But this is where the graphing happens. After 9-4, we're done with graphing. So rejoice. So 9-4, we're going to talk about secant, cosecant, tangent, cotangent. Again, all of these are still written in that same format of where you've got y equals your c plus a, your trig function here, parenthesis b, parenthesis x minus d. Okay? It's all still the same way it's written out. The only thing that we're doing is we're changing the picture. That's the only thing that's happening in this. Okay, we're just changing the picture. A, B, D, C all follow the same information. And again, I just before these notes that I have right here that I put out there, I put out a PDF for you, and here it is. Okay, so this is what a cosecant graph looks like. Okay, they're a bunch of U's and arches like parabolas. Okay, and you got vertical asymptotes. Notice it has the same period as sine and cosine, 0 to 2 pi. So does the secant graph. It has the same period. It starts back here at negative pi and moves towards positive pi. Okay, so again, these two are based off of sines and cosine graphs, and you're going to see me use those sine and cosine graphs to help us do this. Okay, so yeah, I mean, even though these look like parabolas and things like that, the way that I treat secants and cosecants, I treat them just like sine and cosine graphs. You're going to see me do that. And then all I do is draw U's and arches at the tops of and bottoms of their amplitudes. Okay. And again, you have asymptotes here. And I've given you some information about where these asymptotes lie. And again, you got asymptotes down here. Tangent and cotangent, their periods are a little different, so you need to make sure that you watch out for this. Tangent and cotangent, they have periods of pi. Periods of pi. And again, just like kind of like secants up here, tangent starts at negative pi halves and goes to a positive pi halves. Okay? Cotangent starts at 0 to pi. Okay? So watch out for those. And tangent and cotangent graphs look like cubic graphs. Okay? They look like cubic graphs, although the difference is one's going one direction, the other one's going the other. Okay? So tangent starts down and goes up, just like a normal cubic graph. Cotangent flips it, which makes sense because these are reciprocals of each other. So it makes sense that their graphs are flipped. Okay? And the same thing with sines and cosines. Remember, sine graphs start at the axis and go up and then down. Notice at the asymptotes, that's where they hit the axis. And then if I talked about the arch that was in here for a sine graph, notice it's just been flipped over. And the same thing, there was an arch that was right here. All that happened was it was just flipped over because cosecant is the reciprocal of sine. And that's the same thing that happened at secant, because it's the reciprocal of cosine. The cosine graph is right here. It starts up, hits the axis, goes down. And then if I went the other direction, it would start up, going down. Okay? And so if I look at the asymptotes right here, this is where an arch of cosine would have existed. And the reciprocal of that would be to flip it, which makes secant. So these graphs are just flips of the original sine and cosine graph. Okay? They've just been cut at the asymptotes. All right? So know that cosecant and secant have the same intervals or the period of 2 pi. Remember, cosecant starts at 0. Secant starts at, come on, you. Secant starts at negative pi. Okay? And the same thing down here for tangent. There we go. Well, maybe. Maybe it wants to work. Oh, there we go. it's going backwards on me now. So tangent starts at negative pi halves, goes to pi halves. It has a period of pi, so that's different, but not all that much different than what we did. Dang, blue screen back again. There we go. And then down here, cotangent starts at 0, goes to pi, and again, its period is pi. So you got to be careful of some things because it adjusts. We have minor adjustments to what we've been doing, but the A, B, C's, and D's all still follow their job. Okay? So let's take a look at this. So here's our trig function. I don't have to talk about A, B, C, and D again because we already know about that from 9.3. Okay? So if we look at this, thinking about what's going on, okay, we know that here's the A. So A is 1/4. Okay? So that means our amplitudes are going up to a positive fourth and down to a negative fourth right now. So we know that our waves are a little bit smaller, and that's okay. Over here, here's the C. Oh, it's also A is positive, so that means there's no reflection. Okay? All right. So there's the C. So our C value is 2. So that means our graph has been shifted up 2. So our new x-axis is 2. And now we can figure out the amplitudes. So 2 plus a fourth will be 2 1/4. Or in other words, that would be 9/4. 2 minus a fourth would be 1 3/4. Or that would be 7/4. So there's the top and the bottom of our amplitudes. Okay? Now, we'll deal with that here in a second. So over here, we know that this is not written correctly because we need B parenthesis X minus D parenthesis. So we got to fix that just like before. I haven't done anything new yet. Again, like I said, the only thing that's going to change is our graph. Okay? So we've got this 1/2 X minus pi, I believe. Yeah. So again, we're going to pull out a GCF. That GCF is the half. Parenthesis X, divide this by a half. That gives you minus 2 pi. Okay? So that's what we're really working with now. Now you know the real B and C, or B and D. So this is really 1/2 X minus 2 pi. Okay? So here is the real B. B is a half. And again, this messes with the period. What's the period of secant? 2 pi. Okay? Because we know that secant is the same as what function? Cosine. And both of these share the same period, which is 2 pi. Okay? So when I start thinking about this as a graph, I'm going to treat this like a cosine, just so you know. Okay? We'll talk about that soon enough, though. So the period for this, we're going to take 2 pi divided by a half, which gives us 4 pi. Nothing crazy there. Okay? Right here is the D value, but again, remember we think opposites, so the real D value is 2 pi. So that means we move to the right 2 pi. So again, remember in my math lab, you're just going to take this information and use it to your advantage. Yeah, I've shown you that. You just plug it in. You don't really have to do things by hand, but I want to show you what this thing's really going to look like. It's not that bad. Okay? So in order to do this, because we are moving left and right, remember that we're going to solve 0 less than or equal to 1/2 X minus 2 pi less than or equal to 2 pi. Okay? So how do we get rid of a half? We divide by it. And again, this is just like what we verified in the period. So this is 0 less than or equal to x minus 2 pi. And over here, we already know that this should be 4 pi. Now we deal with the phase shift. How do I get rid of minus 2 pi? Add 2 pi, which again verifies why we're moving to the right too. Oops, no division. So plus 2 pi. So now you know your starting mark. You're going to start at 2 pi less than or equal to x less than or equal to, and we're going to end at 6 pi. There we go. So let's go ahead, put our starting mark on here. So I made this a little bit longer over here because I didn't know if we were going to go negative or not. So technically this could be shorter if you wanted to. So that's why I made this side a little bit longer. I didn't know if we were going to go negative. So technically there are no negatives for us. So we're going to start at 2 pi. And we're going to end over here at 6 pi. Notice everything's still the same. I haven't changed anything that I'm doing. Even though we have a new function, it's still functioning the same. Okay, so now we're going to figure out those magic middle numbers. Oops. Come on, Surface Pro. All right. So the exact middle, we'll be taking 6 pi, because that's our largest, plus 2 pi, that's our smallest, divide that by 2. So that will give us 4 pi. That's the exact middle. Okay? To find the small middle, we'll take 4 pi plus 2 pi. Divide that by 2. That gives us 3 pi. And then we'll take and find the large middle, which will be 6 pi plus 4 pi. And we'll divide that by 2, which gives us 5 pi. Okay? So we know that this is 3 pi, 5 pi. All right. So now let's talk about the graph. Okay. Oh, since I erased over here, this should be 2. All right. So I said I'm going to treat this like a cosine graph, and I am. So here's what the cosine graph looks like for this. I'm ignoring secant for right now. I'm just going to graph this because secant should look somewhat like cosine, just flipped. Okay? So remember, cosine starts at the amplitude. And since we're not reflected, it will be the positive amplitude. And then it goes down. Okay? Oh, I need to check something first. Oh, it's fine. It'll work. It's fine. So it starts at the amplitude, and then it goes down. And then it hits the bottom amplitude. And then it hits the axis. And then it hits the top amplitude. Okay? So this, and I'm going to do something special for this. So here is what the cosine graph looks like, and I wanted it to be dotted. This is nothing new. I didn't do anything new there. Okay? Now, if I want to get the secant graph, here's how you do this. Here's how you transform it. Anywhere where you hit the x-axis, or in our words, the 2-axis, that is now an asymptote. So I hit right at 3 pi, that's an asymptote. I hit right at 5 pi, that's an asymptote. Okay? Anywhere where there's an amplitude, That's now the graph of the secant. This guy is going to flip and come up. Oops, still that black stuff. This guy is now going to flip and come up like that. This little arch right there now becomes a U. This piece right here flips up and becomes that guy. That's how you make secant and cosecant graphs. I graph it like a normal sine or cosine function, and then I draw in my asymptotes wherever I hit my axis, and then I just flip everybody in the opposite directions that represented the cosine and sine graph. Okay? And technically, this part right in here, see if I can select it. If I delete that out, there's the secant graph that we were after. Okay? Secants and cosecants graph just like sine and cosine graphs. Now, the part that I said was okay that I messed up on, because I was treating this like a cosine graph, I went from 0 to 2 pi. Technically, I should have used because we're graphing secant, I should have used negative pi to pi. I should have used that. I didn't, but I still got the same graph that I was after. It's okay. You can use either one, all right? You can use either one of these. Okay, because it was fine. Because technically, what I did was, well, I can't really block it out. I ignored this part of the graph. Okay, it still would have happened in my picture, but I ignored that part. Okay, I only showed you from here 0 to this side. Okay, but I stretched it even further. It's fine. It's okay. The ones that we really got to watch out for that is when we do tangent and cotangent. Tangent and cotangent, we really have to make sure that we pay attention to this interval right here, especially since the period has changed. Okay, so be careful with that, just to let you know. But this is fine, even though I use 0 to 2 pi. I technically should have used negative pi to positive pi. Okay, that was my fault. All right, so, but it's all good. That graph still works. Hopefully that helps you see that these really are the flips of sines and cosines. So when I deal with secant and cosecants, I just treat them like sine and cosine graphs, and I go from there. Okay? Yeah. So secants, cosecants, they're just like sine and cosine. All we did is just flip the picture. Notice there was nothing new that I did here other than I flipped. Okay? So I can put that pink graph back in there. There's the cosine graph. But if I flip those pieces like I talked about, you got secant and cosecant. Okay? All right. Hopefully that makes sense. If not, again, I have Zoom meetings. Come talk to me in Zoom meetings. I know graphing, I think, is probably one of the toughest pieces throughout trig that we will deal with. Okay? I think graphing is just a pain sometimes. Okay? All right, so let's talk cotangent and tangent. So I have 2 problems left. Let me do cotangent with you, and then I'm going to have you try tangent on your own. Okay, so you kind of get a feel for things. All right, so again, right here's the A. So we know that A is equal to 1/2. So that means our amplitude right now is going up to a positive 1/2 and down to a negative 1/2. Okay? Here's the C. So C is equal to a negative 1. That means we're moving down 1. Okay. So again, I'm going to draw my graph here. Going to kind of leave some negative because I don't know what's really going to happen. Maybe we go negative, maybe we don't. But we do know that our x-axis is no longer the x-axis. It has moved down 1. So we do know that this guy is really a negative 1. And then now we can deal with the amplitude. So negative 1 plus 1/2 gets you to a negative 1/2. Negative 1 minus 1/2 gets you to negative 1.5, which will be negative 3/2. Okay? So there's A and C done. And then again, do look up here. This is not the proper format for that. So we got to do a little bit of messing around here, a little bit of GCF action. Okay? So 2x, was it minus? Yeah, minus 3 pi. So we're going to take and we're going to divide everybody by 2 because we're pulling that GCF of 2 out. So that gives us this information. When we pull the 2 out, we get x minus 3 pi over 2. Okay. So this is what we're really working with here. This is how it should have been written to get the real b and d. Okay. That's how that should really look in there. So now we know the real b is 2. Okay, so here's where there's some slight modifications. We're dealing with tangents and cotangents now. If you go back to my notes, tangents and cotangents, their period is pi. So in order to find the periods for these, instead of taking 2 pi divided by 2, because that's what secants, cosecants, sines, and cosines deal with, the period on this will be found by taking pi divided by 2. And that actually is the period. There's no reducing there. So we know that these things have gotten shorter. Okay? And then right here, you can see the real d. Okay? Or actually, the supposed d. So the real d is a positive 3 pi halves. So that means we're going to take everybody. Oh, man, come on, you. Grab this. It always does some moving on me every now and then. All right, there we go. I like my little slide to be over here. So that means what's really going on is we're shifting to the right 3 pi over 2. Okay. So let's find our beginning and end points. So if we go and look at this, this is the one where you want to watch these pieces right here. So this is for tangent. Tangent starts at a negative pi halves and ends at a positive pi halves. Well, we're not dealing with tangent. We're dealing with cotangent. So tangent starts at 0 and ends at pi. So we really need to make sure that we pay attention to that right there. All right. So let's come down here. And when we adjust this now, we're working with this. 0 less than or equal to 2 parenthesis x minus 3 pi over 2 less than or equal to pi. That's the interval for cotangent. If it was tangent, then I would have had negative pi halves, positive pi halves. Okay? So watch those intervals for this. So let's solve. So we know that we're supposed to divide by 2, which is what we did in the green. And that verifies that our period is now a length of, I don't know why I put the 2 back there, x minus 3 pi over 2. So that verifies that our period was, in fact, pi over 2. Okay? Now, add 3 pi over 2 because we're moving to the right. That just verifies that because that's how you get rid of subtraction. So we find out that our beginning point is at 3 pi over 2. Our end point will be at 2 pi. Because when you take a half plus 3 halves, it's 2. Okay? So now we know that our beginning point here, 3 pi over 2, our end point, 2 pi. All we need to do is find the middle stuff. Okay? And you know how to do that. So we take our largest to find the exact middle, 2 pi, plus our smallest, 3 pi over 2, divide by 2. So again, I don't know that off the top of my head. Alpha y equals, and then I got 2 plus alpha y equals 3 over 2, and all this is divided by 2. So 7 pi over 4. Okay, our small middle we'll take 3 pi over 2, or sorry, 7 pi over 4, because that's our large value, my fault, plus our small value, which is 3 pi over 2. Let's make that look like a 3. All that divided by 2. So again, go to my calculator, come up here, grab this. Definitely got a lot of rearranging to do here. So alpha y equals, so this was 7 over 4. Our smallest was the 3 pi over 2. Perfect. So that's 13 pi over 8. There's our smallest one. And then to get the large middle, we'll take 2 pi plus 7 pi over 4 divided by 2. So again, going back to my calculator, I'll just grab that first guy, because all I got to do is just change that second fraction. So 7 over 4. And we get 15 pi over 8. There we go. So this guy is 13 pi over 8. This one right here is 7 pi over 4. This is 15 pi over 8. All right. Now we're ready to graph. So with tangents and cotangents, your beginning and your end are asymptotes. And then in the middle are your 3 dots. And the 3 dots either start up, hit the axis, and then go down, or the 3 dots start down, hit the axis, and then go up. Okay? So since we are cotangent, we are going to start up, hit the axis, and then go down. Okay? So our beginnings are asymptotes. Our ends are asymptotes. And then now, since this is cotangent, you start down, you hit the axis, you go up, and then make it look like a cubic graph. And I just did that wrong. I need to take and flip this upside down. That was my fault. Let's undo that. That was the tangent graph right there. So cotangent starts up, then hits the axis, and then goes down. That was my fault. There you go. And there's the cotangent graph for this. Like I said, we're doing all the same stuff as before, just a slight modification on tangent and cotangent, where over here this is pi, okay, because their period is pi. Just a slight modification, but it's all the same stuff. Nothing changes the A, B, C's, and D's. They all still do the same job, just a different picture. Okay? Try tangent, and that will end 9-4. Okay, so here's our A. So A is equal to 3. That means the amplitude is at 3. Up at a positive 3 and down to a negative 3 so far. Here is our C. So our C value is a negative 2. So that means we're going down 2. Okay. So come right here. I'm going to put some negative on there because I don't know what's going to happen. Looking at this, I definitely think that we're going to go negative. I might have to adjust my y-axis just kind of looking at this. We know that our new x-axis is at negative 2. And if I go down 3, that puts me at a negative 5. If I go up 3, that puts me at a positive 1. Okay? So now to start messing with the fun stuff. Again, this is not written correctly, so we've got to fix that. For x plus pi. So we're going to pull out a 4. That gives you x plus pi fourths. So this is 4x plus pi fourths. That's how it should really look. So now here's our b. So b is equal to 4. To find the period, remember we're dealing with tangent here. Okay? Tangent and cotangent, their periods are smaller. Remember, their periods are only a length of pi. So we're going to take pi divided by 4. And that does not reduce. So there's the period. Our length is pi over 4. Okay? Here is the so-called d. So since that is positive there, the real d is a negative pi over 4. So that means we're moving to the left pi over 4. Okay? All right. So now let's find the beginning and end points. Remember over here, this is important. Tangent starts at 0 to pi, but we don't, cotangent starts at 0 to pi, but we don't have that. So this is the tangent graph. It's all the way over here at negative pi halves. So this is the interval we're going to work with. Okay? So really watch that for tangent and cotangent. For secant and cosecant, it's fine. Okay? I showed you that it was okay a second ago. All right, so we're going to start at negative pi over 2 less than, put our stuff in the middle, which is 4 parenthesis x plus pi over 4 less than or equal to positive pi halves. I think a second ago I said tangent went from negative pi to positive. It's negative pi halves to positive pi halves because that's a distance of pi. Just want to make sure I clarify that. So divide by 4, divide by 4, divide by 4. Oops. Computer was lagging a little bit. That's why it doubled up on that. Okay. So this gives us negative pi over 8 less than or equal to x minus pi over 4. Plus pi over 4 less than or equal to pi over 8. And if you look at that distance, this is 1/8 and that's 1/8. If I add 1/8 and 1/8, that gives me 1/4, which verifies that, yes, this is still a distance of pi over 4. Okay? So now we deal with the moving left pi over 4. So we're going to subtract pi over 4 to both of these. Minus pi over 4 to both of these. So this right here, this gives us negative 3 pi over 8. Okay? Less than or equal to x less than or equal to this one right here gives us negative pi over 8. So all of our graph is completely on the negative side. So again, this is where I said, well, I might have to do some adjusting. So let's adjust this guy. So I'm going to put the y-axis right there. This is the positive one. Down here, this is the negative 5. Okay? So we know that we start over here at the negative 3 pi eighths, because we always work left to right. And we know that we're going to end over here at negative pi over 8. So now we just find the middles, just like everything else. Okay? So the exact middle, we'll take negative 3 pi over 8 plus negative pi over 8. Divide that by 2, which gives us negative pi over 4. Okay? Pretty sure. Let me double check that. So alpha y equals negative 3 over 8, not 88, Mr. Armstrong, plus alpha y equals 1 over 8, sorry, negative 1, divide by 2. Oops, I got rid of the negative up here. Stop making mistakes, Mr. Armstrong. Yep, negative 1/4. So negative pi over 4. Okay? The small middle. Take negative 3 pi over 8 plus negative pi over 4 divided by 2. And I keep clicking the wrong one. So let me come up here, grab this guy. So we are changing this guy to a negative 1/4. So negative 5 pi over 16. And then the large middle will take negative pi over 4 plus negative pi over 8 divide by 2. And going to our calculator, we'll come up. And all we need to do is change this negative 3/8 to a negative 1/4. Okay. So negative 1 over 4. And we get negative 3 pi over 16. There's our middles. 3 pi over 16. Okay. So negative 3 pi over 16, negative pi over 4. If I remember right, this is negative 5 pi over 16. Double check that last one. Yes. Okay. And now we're ready to graph. So remember, the beginning and the ends are automatically asymptotes. And now we just think of a cubic graph. Tangents look like the cubic graph. So the cubic graph starts down first, then comes up, and then comes up again. So now all we do is just curve it. Whee, curving. Excuse me. There is the tangent graph for this. And that's it. That's what 9.4 is all about. It's the same stuff from 9.3. It's just a different picture. Watch out on tangents and cotangents for that period change and what you're using for that interval. So tangent goes from negative pi over 2 to pi over 2. Cotangent starts at 0 and works out to pi. So just watch out for that. But other than that, it's the same stuff. Again, if you have questions, comments, concerns, email me, text me, call me. Let's work in a Zoom session. We can talk about graphs. Like I said in 9.3, I think this is one of the tougher pieces of the trig unit that you will run into. And this really is all the graphing there is. So again, just like in the assignments, most of these graphs are multiple choice, or you'll be plugging in the amplitude, the vertical shift, the period, the phase shift, and then it will do all the work for you. You don't really have to do any of these by hand, okay? But knowing what it looks like by hand, that's definitely going to help you find the pictures and things like that, okay? And with that being said, that ends 9.4 on graphing secants, cosecants, tangents, cotangents.